In recent months, American military analysts and Air Force officers have increasingly returned to the same topic, one that until quite recently seemed almost off-limits. The subject is the future of the B-2 Spirit, the legendary stealth bomber that remains one of the most expensive and secretive aircraft in history. Although the Pentagon has been focusing primarily on the B-21 Raider for several years, the B-2 modernization program has not only remained active but, apparently, is moving to a fundamentally new level. According to information emerging from closed briefings and reports, the issue is no longer simply extending the aircraft's service life and upgrading its communication systems. Instead, there is an attempt to transform a machine designed in the 1980s into a platform capable of operating with virtually no crew. Officially, everything looks fairly routine. Northrop Grumman continues to carry out a contract worth up to $7 billion, scheduled to run through 2029. In February 2026, the first B-2 flight took place with the new Adaptive Communications Suite 4.0, developed by Sierra Nevada Corporation. This system is intended to enable operations within the concept of joint all-domain command and control. At the same time, the open architecture Spirit Realm 1 is being implemented, allowing new software and weapons to be integrated much more quickly. Electronic warfare systems have been upgraded, low observable coatings have been improved, and last year the Air Force quietly acknowledged that the aircraft's maximum combat payload in certain configurations could reach 60,000 pounds. The B-2 has already demonstrated the ability to deploy LRASM anti-ship missiles during exercises in the Pacific. All of these are facts that can be found in open sources and budget documents. But behind this official picture, according to several sources familiar with discussions inside the Pentagon, a far more interesting and controversial story is unfolding. According to information that has at various times been passed to journalists by Defense News, The War Zone, and several European publications specializing in intelligence matters, senior officials at the U.S. Department of Defense personally raised the issue last year of involving organizations associated with Elon Musk in the B-2 modernization program. The discussion was not about traditional contractors such as Northrop Grumman or Lockheed Martin, but about Tesla and, above all, xAI and its Grok model. Sources claim that the idea did not emerge out of nowhere. Following operations against Iran, during which American forces used more than 2,000 munitions against 2,000 targets within 96 hours, the Pentagon received direct confirmation of the effectiveness of the Grok-Gov model. This specialized version of the neural network, adapted for operation within classified environments, had already been used in the Maven Smart system to accelerate targeting and strike planning. Official statements on this matter appeared in court documents related to environmental lawsuits against xAI data centers. If Musk's artificial intelligence had already helped coordinate strikes on a strategic scale, then the logical next step appeared to be an attempt to integrate it more deeply, directly into the onboard systems of the most valuable strike platforms. This is where, according to insiders, the request for Tesla's involvement emerged. Not as an aircraft manufacturer, of course, but as a source of capabilities that the traditional defense industry urgently lacks: rapid software iteration, experience developing highly autonomous systems, vertical integration of hardware and software, and, most importantly, the ability to work with massive volumes of real-time data. Tesla has been developing autopilot and full self-driving systems for many years. Optimus and the company's other projects have demonstrated just how aggressively Musk is willing to invest in autonomy. For a bomber that must fly deep inside enemy territory for hours, these capabilities look extremely attractive. What exactly could such an integration provide? First of all, a qualitative leap in autonomy. The modern B-2 is already vastly different from the aircraft of the late 1980s. The processors are now 1,000 times faster, an open architecture has been introduced, and situational awareness has been significantly improved. Yet the crew remains critically important, moving to a mode in which the aircraft could independently carry out a substantial portion of a mission, from navigation under conditions of complete radio silence to selecting targets and even evading threats, would require a fundamentally different level of artificial intelligence. Grok, trained on enormous datasets and already tested under combat conditions at the targeting level, could theoretically become the core of such a system. It could analyze sensor data in real time, cross-reference it with current intelligence, propose route options, and even coordinate operations with collaborative combat aircraft unmanned systems, which the Air Force is already actively testing. Second, the goal could be to reduce dependence on humans during the most dangerous phases of flight. The B-2 remains the only platform capable of reliably delivering heavy penetrating munitions deep into heavily defended airspace. Every sortie represents an enormous risk to the two pilots sitting inside a cockpit aboard an aircraft worth billions of dollars. The ability to shift some missions to a fully unmanned mode, or at least to a one-pilot plus powerful AI configuration, would radically change the risk calculation. For a strategic bomber capable of carrying nuclear weapons, such a step would have enormous significance. Third, Tesla could potentially bring its own approaches to manufacturing and maintenance. The B-2 is notorious for its staggering flight hour costs and the difficulty of maintaining its stealth characteristics. Tesla's experience with mass-producing complex systems could theoretically help simplify certain procedures, although this immediately raises numerous questions about compatibility with Northrop Grumman's existing industrial base. However, this is precisely where things become most interesting. So far, there is not a single official confirmation that Tesla or xAI has actually been granted access to B-2 work. All references remain at the level of insider claims and anonymous sources, and that is hardly surprising. A strategic bomber is not a commercial electric vehicle. Completely different access rules apply, along with different certification requirements and entirely different levels of secrecy. Traditional contractors guard their territory fiercely. The Air Force has historically been extremely cautious about transferring control of critical systems to commercial companies, even when those companies are led by someone with direct access to the White House. There are also deeper reasons for skepticism. A fully autonomous strategic bomber, particularly a nuclear-capable one, raises questions to which there are still no definitive answers. How can it be guaranteed that artificial intelligence will not make a wrong decision under conditions of electronic warfare and deception? How can software that is continuously updated be properly verified? How could a commercial neural network be incorporated into the strict framework of nuclear certification? And finally, how sensible is it to make one of the most valuable military systems dependent on a company whose priorities and even political views may change? Opponents of the idea also point out that the B-21 Raider was designed from the outset with autonomy in mind. The aircraft already has an open architecture. A virtual AI-based co-pilot concept has been discussed, and although a two-person crew has so far been confirmed for operational service, the potential for unmanned modes is built into the design. Why invest in a deep overhaul of the aging B-2 if a newer and more advanced bomber will begin entering service in meaningful numbers within a few years? Supporters of the opposing view offer a simple response. The B-21 is not yet in service in sufficient numbers, while the B-2 is already the only means capable of performing certain classes of missions. Until the Raider reaches full combat readiness, the Spirit remains indispensable, and if there is an opportunity to substantially increase its autonomy and survivability using relatively modest resources by the standards of strategic weapons programs, then abandoning that opportunity would be foolish. Especially considering that Musk's artificial intelligence has already demonstrated its usefulness in real combat conditions. For now, however, everything remains in a gray zone. The Pentagon publicly speaks only about the continuation of modernization, new communications capabilities, improved situational awareness, and the integration of advanced weapons. There have been no mentions of Tesla or Grok in connection with the B-2. Sources who previously spoke about the personal interest of senior officials have become noticeably more cautious in recent months. Some claim that the idea has encountered serious resistance within the Air Force and among traditional contractors. Others say that negotiations are continuing under a tight veil of secrecy. Still others hint that certain elements are already being tested on ground-based systems, but that their installation on an actual aircraft is still a long way off. The truth will most likely become known only when a new B-2 configuration makes its first public flight, or when sufficiently transparent language appears in budget documents. Until then, We will be dealing with the classic situation in which rumors move faster than reality, while reality remains hidden behind security classifications. But the very fact that such discussions are taking place at a high level says a great deal. The US military is seriously considering the possibility of radically increasing the autonomy of its most valuable strike platforms. And if Tesla and XAI capabilities really do become involved in this process, the consequences could extend far beyond simply upgrading one type of bomber. It would mean that the boundary between commercial artificial intelligence and strategic military systems has finally become blurred. It would mean that the speed at which new technologies are introduced into the defense sector could increase dramatically. And it would mean that in future conflicts, decisive importance would be attached not only to stealth technology and range, but also to the quality of onboard intelligence capable of making decisions faster and more accurately than a human. For now, however, all that remains is to wait. If a new version of the B-2 really does emerge in the form described by insiders, it will become one of the clearest tests of how far the Pentagon is prepared to go in partnering with private technology giants, and of how much such a partnership could alter the balance of power in the air. Continuing this line of reasoning inevitably leads to a broader question about how exactly artificial intelligence could change the very nature of strategic aviation. If we assume that the discussions about involving Tesla and XAI in the B-2 program have a real basis, then this is not simply a matter of replacing the crew with algorithms. It is about creating a machine that would think differently from any bomber that came before it. Grok has already demonstrated the ability to process enormous streams of intelligence data and produce possible courses of action within compressed timeframes. In an environment where the B-2 enters the range of modern air defense systems, where communications may be completely suppressed and navigation signals distorted, onboard intelligence of this level could become a decisive factor. It could dynamically reroute the aircraft in real time, assess emerging threats, select alternative targets, and even coordinate operations with unmanned wingmen already being tested under collaborative combat aircraft programs. Analysts familiar with classified discussions note that this is precisely the aspect attracting the greatest interest among some Pentagon leaders. The classic B-2 has always been an aircraft that relied on meticulous advanced planning and an exceptionally skilled crew. Any deviation from a prepared scenario required pilots to make immediate and precise decisions under conditions of extreme uncertainty. Artificial intelligence trained on data from real combat operations, including the strikes conducted in 2025 and 2026, could theoretically take over a substantial portion of this cognitive burden. Moreover, it could work with sources of information that a human simply would not have time to process. Data from satellites, distributed sensor networks, other aircraft, and even ground-based electronic intelligence systems. Yet this is also where the greatest danger lies, one that skeptics within the Air Force itself are increasingly discussing. A strategic bomber, particularly one carrying nuclear weapons, cannot afford algorithmic hallucinations. In commercial applications, a neural network error may cost money or reputation. In the case of a B-2, an error could trigger an escalation to a level that nobody would want to test. That is precisely why, according to sources familiar with the position of several generals, there is strong resistance to handing critical functions entirely over to commercial models. Even if Grok has already been used for targeting within Maven, that process has still remained under human control. Transferring the same logic directly onto an aircraft that may spend hours operating under complete radio silence represents an entirely different level of responsibility. There are also purely institutional obstacles. Northrop Grumman has spent decades building a closed ecosystem around the B-2. The Spirit Realm 1 open architecture has already represented a major step toward greater flexibility, but it nevertheless remains under the control of the traditional contractor. Bringing in a company such as Tesla, accustomed to completely different development cycles and a much greater degree of public visibility, is viewed by many as a threat to established structures. There is also the question of access to highly classified data. Training or further training a model for deep penetration missions would require information that the United States has never provided to civilian organizations on anything approaching that scale. Even with special versions of Grok designed for government use, this barrier remains extraordinarily high. The geopolitical context makes the entire debate even more acute. In the Pacific theater, Chinese forces continue to rehearse scenarios in which U.S. carrier strike groups and forward bases come under sustained pressure. The ability to strike critical targets deep inside the territory of a potential adversary remains one of the key elements of deterrence. The B-2 is still the only platform capable of reliably carrying out this mission with heavy penetrating munitions. If it can be made significantly more autonomous, this would change the risk calculus not only for American pilots, but also for those planning potential conflicts on the other side of the Pacific. An aircraft capable of maneuvering for hours inside a restricted zone without risking the loss of its crew would represent an entirely different kind of threat. It could be used more aggressively, more frequently, and with lower political costs. This point, according to a number of analysts, could prove decisive in the debate over bringing new players into the program. If the traditional modernization path offers only evolutionary improvements, while the involvement of Tesla and XAI capabilities promises a qualitative leap, pressure to conduct such an experiment will grow. This is especially true while the timelines for deploying a fully operational fleet of B-21s remain subject to cautious assessments, and the number of operational B-2s amounts to only a couple of dozen aircraft. Each one is a strategic asset that must be preserved. The possibility of reducing risks to personnel while maintaining or even increasing combat effectiveness looks extremely attractive to those responsible for planning actual operations. At the same time, the opposite scenario cannot be ruled out. It is entirely possible that the discussions about Tesla were merely a way of testing the waters, essentially a means of gauging the reaction of traditional contractors and Congress. In the American defense system, such trial balloons are launched regularly. Sometimes they lead to real changes. Other times they quietly fade away, leaving behind nothing but rumors. So far, there is not a single document or public statement confirming an official decision to bring Tesla or XAI into the program. There is only a chain of anonymous reports that coincide on key details, along with indirect signs that Musk's artificial intelligence has already penetrated decision-making processes at higher levels. What happens next will become clear only through the results. If, over the next year or two, the B-2 gains new capabilities that clearly go beyond the announced ACS and Spirit Realm programs, or if the aircraft begins demonstrating behavior more characteristic of autonomous systems than of a conventional manned bomber, then the rumors will have received confirmation. If, on the other hand, modernization remains focused on the familiar areas of improving communications, stealth characteristics, and the integration of new weapons, it will mean that the idea was either rejected or postponed until more mature and controllable versions of artificial intelligence become available. In any case, the very fact that such discussions are taking place shows just how far the rethinking of the human role in strategic aviation has progressed. Just 10 years ago, the idea that a multi-billion-dollar bomber could fly a nuclear or critically important conventional mission without a crew seemed almost science fiction. Today, it is being discussed at a level where real decisions about resource allocation are made. And if the people and technologies behind Tesla and Grok really do become involved in this process, the B-2 Spirit could become more than an upgraded version of an old aircraft. It could become the first true hybrid of a conventional strategic bomber and a next-generation autonomous strike system. The consequences of such a step would extend far beyond a single aircraft type. They would affect the entire logic of air power employment, the entire deterrence system, and ultimately the balance of power among the world's leading powers. For now, all that remains is to wait for the moment when the new configuration either appears in public or finally disappears into the archives of classified programs. All of this is happening against the backdrop of an accelerating technological race, where time works against those who hesitate. China is already demonstrating systems capable of detecting even low observable platforms through passive signatures, while Russia is expanding its long-range interception capabilities. Under such conditions, every additional percentage point of B-2 autonomy becomes a strategic resource. If the rumors about the involvement of Tesla and Grok prove to be true, then within a few years we could see a completely different Spirit, a machine that would not simply fly, but make decisions at a level previously accessible only to entire command staffs. If, however, these discussions remain nothing more than echoes of internal disputes, the B-2 will continue along its current path as an extraordinarily sophisticated, yet still deeply human-dependent instrument. Either way, the moment of truth is approaching. The new version will either confirm the boldest scenario of a technological breakthrough or finally bury it beneath the classification markings of a secret program. And then it will not be insiders, but the aircraft themselves that reveal just how far the Pentagon was prepared to go.